Welcome to the Bookman's Corner. I'm Lois Lindstrom. There have been more than 22,000 traceable objects launched from Earth into space. However, only about 1,000 of these objects are active satellites. The other 96% can be classified as space debris. Joining me today is guest author Dr. Joseph N. Pelton, who wrote the book Space Debris and Other Threats from Outer Space. Thanks for being here, Joe.
Thanks. Happy to be here.
And in your book, Dr. Pelton writes that the growing amount of space debris in the skies could make it difficult in the future to access space for critical applications such as communications, navigation, weather forecasting, military surveillance, nuclear monitoring, and even space exploration. In his book that was published in 2013, he discusses coping strategies for space threats in the near and longer term. Our viewers should know that Joseph Pelton is the immediate past president of the International Space Safety Foundation. He is the former dean of the International Space University and director emeritus of the Space and Advanced Communications Research Institute at George Washington University. He's been active in the Arlington, Virginia community for many years as president of the Arlington County Civic Federation. He is widely published with some 35 books written, co-authored, or co-edited. I have severely edited his bio in the interest of time, but he is a real expert on space and satellite communications. Joe, many thought that our space debris problem, which had been left in orbit for the past several decades, was unlikely to collide. I mean, what causes the orbital debris problem, and why is it getting worse?
Well, back in 1970, there was a NASA scientist named Don Kessler who said, this could be a problem if we don't take better care of the debris. And everyone said, oh no, it won't be a problem. And then over the years, it started to build up. And then we had a collision between a Iridium communication satellite and a Russian satellite. And then,
now, what year was that?
That was back around 2003.
Okay.
And then we had another incident, if you will, where the Chinese shot down an old weather satellite, and that both of those events created 3,000 major new elements of space debris. And now we have so much space debris out there, particularly in low Earth orbit. We have about 10,000 tons of space debris out there, and 45% of that is in low Earth orbit, close to Earth. And so now
it is going in an orbit around the Earth.
Yes, going around orbit Earth, and that now big debris elements are crashing into each other. And so this, unless we start doing something about it to lessen that problem, it's going to get worse.
Yes.
And the UN has created new procedures and processes, and the national governments do due diligence to make sure when you're launching that you don't leave the upper stage rocket motor and things like that.
Interesting. Now, I want to ask you, how is your book, Space Debris and Other Threats from Outer Space, how is this book organized?
Well, basically, we talk first about space debris, then we talk about major asteroids or near-Earth objects that could crash into Earth that like killed off the dinosaurs. And then finally, we talk about the solar storms. And this is something that people don't really know about.
That's
but
right.
There are major solar storms that could knock out our power systems, like it did in the Montreal event in 1989. And it can also knock out our satellites. So we really are launching so much technology and putting so much technology in place that we're much more vulnerable than we used to be.
And what about other cosmic dangers? I mean, why should we be concerned about them? You mentioned this in your book about asteroids and...
Right. Well, as I say, those are the three things of the first the space debris, then the asteroids and near-Earth objects and comets that could crash into Earth. And it takes only about a 30 to 40 meter asteroid to wipe out like New York or the San Francisco Bay Area or what have you. And that we really haven't got a very good inventory of asteroids down to that size. And then finally, we have the issue of these solar storms.
Right,
and
right.
there can be solar flares that are radiation They can do very bad things. And then there is also the coronal mass ejections, where we're talking about mass ions that hit the Earth with tremendous force, and it can take out our power systems and do other damage.
Well, in your view, what space threat should concern us most?
Well, all three of them should concern us. There is a matter of time frame. In terms of time frame, the most urgent thing, in my view, is better protection against these solar storms, because NASA has done a study and projected that there's a 12% chance in the next decade that we'll have a major solar storm that will wipe out our electrical power systems and maybe do damage to, like, our GPS navigation
very
satellites. And that can do
results, yeah.
a lot of damage that we don't really understand how dependent we are on satellites today.
Yes, yes. Well, in 1980, there were fewer than 5,400 sizable space objects spinning around in low Earth orbit. I mean, how many are there now? And please elaborate on space debris and the Kessler syndrome.
Right. Well, the thing is, it's complicated. That we are tracking about 22,000 objects that we call space junk today.
Okay.
And this is done by the Air Force and the facilities
Around the globe, right?
they have facilities to track everything around the globe. And of course, these are also to watch out for missiles, but also to make sure that orbital debris is not crashing into the space station, for instance, and other vital satellites. But the thing is, the problem is getting worse, and that collision between large objects make like 3,000 new debris elements. So it becomes like a cascade avalanche of debris, begets more and more debris.
Yes, yes. Now, what was the Carrington event, and what would happen if that were to happen today?
Right. Well, in 1859, there was a solar astronomer in London who was observing the sun, and he said, "What the heck is going on?" Because there was this huge thing, it looked like a dragon on the surface of, and he called the staff together and they said, "Look at this." And then a day later, wham, we had a really major coronal mass extinction event. And when that happened, telegraph offices caught on fire. The northern lights came down to Cuba and Hawaii and so on. And the point is, we have no idea what that would do today.
Now, did it affect food production, you think?
Well, the main thing is that it affected anything that was electrical.
Okay.
But in those days, it was only the telegraph.
Okay.
But today, we have computers, we have communication
yeah,
systems and so on. And more recently, in 1989, we had what was called the Montreal event, which wasn't at all like the Carrington event. But that wiped out power from Chicago to Montreal. It did a whole lot of damage.
For how long?
Well, it took weeks to months to restore all of the transformers. I have an image of a Chicago transformer before and after, and it was totally fried by this event. And the point is, 200 years ago, we didn't have all of this infrastructure, electrical infrastructure, and power dependency.
So
but today,
we're
when
very
it happens,
vulnerable. Yes,
it makes us very, very vulnerable.
Yes. Well, why do you feel that the NASA mandate from the U.S. Congress in trying to find asteroids larger than 140 meters is really wrong-minded, in fact, perhaps dangerous?
Well, the thing is that they started out and they told NASA, let's get a track for things that are larger than a kilometer in size. And so NASA started on that. And then some scientists said, you know, that really is not sufficient. And so Congress told NASA, well, track it down to 140 meters in size. Well, the trouble is that we now know that a 30 to 40 meter asteroid can wipe out a major city. And that, unfortunately, the smaller the size of the asteroids, the more and more there are of them. And we have just a very minor inventory of what the the larger ones are.
Okay.
And that we're going to see a video, I think, later,
Yes.
and in it it'll explain by former astronauts why they are putting up a new satellite that will be able to track down to 30 to 40 meters in size.
Great.
And that we really need this to protect our cities. Because,
good. Yeah, that's right. It's vital. Which are the 3 worst countries committing the orbital debris problem, you think?
Well, actually, China, the U.S., and Russia.
Okay.
Europe comes in 4th.
Okay.
And the thing is, we now have new procedures in place to make sure that the top stage of the rockets come back down, that we don't use explosive bolts that we used for a long time. That there were all these things that we were doing that were really pretty stupid in terms of leaving space junk out there. But the thing is, we really do need to start a new program, and I actually have a new book coming out next month that basically talks about some of these new procedures to be able to break the junk down.
Will this talk about how you deorbit a satellite, and will there be more collisions when you do that?
Well, no, because the main problem is low Earth orbit, and so those things will come down pretty immediately. But unfortunately, it's pretty expensive with the technology we have today. But there are some very new ideas. There are the things that you have a thing that you could shoot with like a bow and arrow into a satellite, and it puts a expandable net, and that creates drag on the atmosphere, and that brings them down much more quickly. So you can have this one satellite goes around and shoots its one bow and arrow, and then that one goes down and goes to another one and another one, so that instead of just one mission and one satellite down, it can maybe bring down 15 or so.
But when it comes down, of course, we want it to come down into the ocean versus onto land, right?
Right. Well, this is a problem of that today, these things that come down, they just come down randomly. And of course,
they can land anywhere, right?
Well, the Pacific Ocean is the main target because that's actually the biggest target on Earth.
Right.
And if we bring down the International Space Station, that's where it will come down on a controlled basis.
Okay.
But the thing is, we really don't need to worry so much about the space junk coming down. In other words, it's not 30 to 40 meters in size and doesn't have the kinetic energy of an atomic bomb.
Okay, thank goodness.
Which is what we're really worried about with asteroids.
Right.
The main thing is just to get them down so it's not colliding and creating more and more space debris.
Right. Well, Dr. Pelton, as you mentioned earlier, you suggested we view a short video from YouTube which describes in detail the space debris problem. So let's take a look at this. Okay.
The sun, one of the greatest wonders of the world. We rely on it as a friendly neighbor to light our world, and thus we sometimes forget what a raging nuclear fusion-based inferno it actually is. In late September 2013, part of a 200,000 kilometer long filament that recently ripped through the sun's corona, burning at a heat up to 1,800,000 degrees Fahrenheit, leaving behind what looks like a glowing canyon. The sun provides us the energy that is essential to life on Earth. In fact, the sun provides us 10,000 times more energy than we use. But solar flares and coronal mass ejections are also a constant threat. The Carrington event of 1859 set telegraph offices on fire and brought the northern lights aglow down to Cuba and Hawaii. If repeated today, this might wipe out the world's electrical grid, cause aircraft to fail, and wipe out our satellites.
called the Kessler syndrome, and he back in the 60s and 70s said if we don't take care and stop using explosive bolts and leaving fuel in rockets that can explode, over time this debris is going to build up, and at a certain point it will reach where it will just cascade and create more and more debris and basically go out of control and deny us access to space.
Swarms of debris in low Earth and polar orbits now threaten weather and communication satellite constellations, as well as the International Space Station, the Hubble telescope, and even the new James Webb telescope that promises to let us see back to the beginning of time.
What's called the Kessler syndrome is really nothing more than the way nature operates with orbits that cross one another. And they'll eventually collide with one another. They'll create smaller debris and a certain amount of larger debris. And then that larger debris can go on and cascade to create even more debris, and you can get a runaway cascading effect. When that's applied to low Earth orbit, that phenomena is taking place right now, but at a very slow rate. At about once every 10 years, we're seeing a collision between large objects, and then but that rate will increase even if we don't add any new objects to Earth orbit.
Asteroid impacts are tremendous events, and once you have a good solid orbit on them, you can predict 100 years ahead of time whether there is a likelihood of an impact with the Earth.
There are an estimated 500,000 to 1 million asteroids that are 30 meters or larger in size. At 30 meters, these are potential city killers. We now know that a 5-kilometer wide asteroid crashed into Earth 65 million years ago, and the residue rose up and blotted out the sun, and it killed off the dinosaurs and 2/3 of all species in the world's worst mass extinction event. The proof is still with us in the crater that we can still see today on the coast of Mexico. A bus-sized asteroid swept by Earth on May 2nd, 2014. It was detected only 3 days earlier. It had the kinetic energy of a nuclear bomb.
If they hit Earth, bad things can happen. And so, for example, the asteroid that hit in Tunguska in 1908 was about 40 meters across. Okay, and that caused an area of devastation roughly the size of the San Francisco Bay Area. There's a million or so objects whose orbits cross Earth's orbit. And we currently know of about 10,000 of them. Our project, called Sentinel, is to launch a telescope, a space telescope, to catalog and track and make this map of all the asteroids in the inner part of the solar system.
Today, new research is trying to develop innovative technology that can allow us to remove the largest debris elements. This same technology may allow us to start on-orbit servicing to make very expensive satellites live longer.
Looking at the Earth from space, you realize what a precious place this is.
You realize that we have a responsibility to continue safe operations on board Spaceship Earth. And that means protecting humanity.
Joe, interesting. Don't we need penalties and incentives to mitigate the problem of space debris? I mean, what kind of incentives might work?
Well, it took almost 18 years for the UN Committee on Outer Space Affairs to agree on procedures that are still voluntary to get things. So putting into place penalties is a very difficult thing when you get to the international community.
Right, who's going to police it, right?
Yeah. So I'm actually involved with McGill University right now on a study
of Canada,
on global space governance. And that most of what we're looking at is not new space treaties, because we got 5 space treaties in place back in the 1970s and nothing since. So it's much more like model national laws, what's called transparency and confidence building measures and so on, where space spacefaring nations sort of agree these are the things that we should do.
So is it working out? Is China and Russia, are they cooperating? Are they?
Not as well as we would like.
Okay.
But the U.S. itself has done some things wrong in the past, and so getting these model laws in place. Actually, France has developed a new model law that creates real penalties against space debris, so that if you launch a satellite and it creates launch debris, you are in trouble with the French government.
Well, that's
basically, you
interesting.
can sort of go to jail or at least pay a big fine.
Well, that's good. At least the French are
Right.
being determined to try to
But
slow
the point
this
is,
down.
we're hoping that other countries will follow their example. And the U.S. has similar, not laws, but regulations in
Okay.
place. And so it's sort of like getting all of the players to play nice and to follow the same rules.
Right. Well, you know, you served as the former dean of the International Space University, and I just thought you might briefly tell our viewers, what is the International Space University?
Well, the International Space University is actually in Strasbourg, France, and it has several programs. It has a master's program that people from all over the world come to study, and then it also has a summer program, or what we call a space studies program, that's 9 weeks long, that goes around the world. We've been in China, we've been in the U.S., we've been in Thailand, we've been all over Europe, and so on. And the thing is, what's different about this is that we are interdisciplinary studies. So in study this way, we go this way. So we study space and astrophysics and space and satellite communications and space engineering and space law and space business. And then the students who come from all these different disciplines, they do interdisciplinary studies about how do you create a colony on the moon, and how do you make it work technically, how do you make it work in terms of business, how do you make it work in terms of laws and regulations.
Interesting. And how is it funded? I mean,
Well, the thing is, it's grown over time, and more space agencies and aerospace companies, and of course there are scholarships that come from the space agencies and so on. And what's interesting today is when you go to big space conferences where 5,000 people come together, the one most identifiable group are people who are graduates from the Space University, people who have taught for the Space University, people who have helped fund the Space University, and so on. And so, like the head in Washington, D.C. of the European Space Agency is a graduate of the space, the German space group.
okay, so there's a lot of space experts are accumulating from this.
The usual suspects now are people who have these ties to the International Space University.
Fantastic. Well, you know, you are an award-winning author and editor of some 40 books and over 200 articles in the field of space, satellite communications, and future technologies. Which of your books was nominated for the Pulitzer Prize? And tell us about that book.
Well, that was called Global Talk, and it actually did win the International Astronautical Society's Literature Award. And it was basically about satellite communications and how it changed the world and how different the world is due to satellite communications, due to global TV broadcasts, and how it impacted like the closing down of the Vietnam War, to teleeducation. Probably the most significant thing I ever did in my professional life when I was at Intelsat was creating a teleeducation program in China, which more than 10 million students now are getting education via satellite in rural China.
Amazing, amazing. And just briefly tell us about, you received the Arthur C. Clarke Foundation's Lifetime Achievement Award in 2001. Tell us quickly about Arthur C. Clarke and your work on his behalf.
Well, Arthur C. Clarke is known for science fiction and 2001, The Space Odyssey.
Yes.
But he first conceived of the geosynchronous communication satellite we sometimes call the geosynchronous orbit, the Clarke orbit. And he was a real hero of mine. I got him to work with us at Intelsat for an exhibit in Geneva, where the International Telecommunications Union is.
What year was that?
This was back in '84, I guess it was. And he and I developed a sort of a friendship. I visited him in Sri Lanka where he lived and
Yes.
played table tennis with him and so on. And we got him to agree to set up the Arthur C. Clarke Foundation as a part of World Communications Year. And that was back in 1983. And the foundation has done all sorts of things, educational grants and scholarships and awards and so on
Well,
since.
it's wonderful, and it's furthering our interest in and our desire to explore our universe, right?
Right.
And well, I wanted to ask you: are there key international organizations that are addressing the orbital space problem? Are there like two or three that people would know about?
Well, the main one is the International Telecommunications Union in Geneva, and they allocate frequencies, and they then work also with what's called the UN Outer Space Affairs Committee.
Okay.
And that's in Vienna. And so those two groups, the UN Committee on the Peaceful Uses of Outer Space and the ITU, but there are lots of other groups as well, but those are two main ones.
What is the potential impact of asteroids or comets affecting us in the 21st century?
Well, the thing is, we don't really know. We do know that the impact of asteroids is at least 4 times greater than we previously thought, and this is by using the system for monitoring nuclear explosions.
Okay.
But it also shows up when a big asteroid hits, and from that we know that it's 4 times at least more common than we thought.
Ugh, okay.
And that we had the event in Siberia that people sort of woke up to, but just in last year we had a asteroid that went by that missed us only by 17,000 miles. Well,
Whoa.
that sounds like a lot, but in astrological terms,
that's pretty close. That's
pretty damn close.
Well, I would like to say I wish we had more time to talk about these things, but we now need to tell our viewers where they can find your book in Arlington.
Well, the best place is on Amazon.com or
Okay.
BarnesandNoble.com. And they put my name in, and actually lots of stuff will come up.
You
including
have
my
many,
new-
many
new
books
book.
that they
Right,
can be reading
right,
about.
Right, so I have a new one out on Arthur C. Clarke, and I also have one out on active orbital debris. I'm working on one right now on cybersecurity.
Well, Joe Pelton, it's been great having you on the Bookman's Corner. Thank you so much for joining us today.
Pleasure to be here.
And please join us again next month for a new edition of the Bookman's Corner. I'm Lois Lindstrom.